Hey everybody, in this video we are going to learn about section 5.5, which is using different inequality theorems in triangles. The first one that we're going to start with is the exterior angle inequality theorem, which says that any exterior angle of a triangle must be greater than either of its corresponding remote interior angles. So if we take a look at the diagram, right, angle 4 is our exterior angle, and this theorem says that it must be greater than either of the two remote interior angles. So the measure of angle 4 would be greater than the measure of angle 1 and greater than the measure of angle 2. So we're going to look at each set of angles here and see if we can apply this theorem. So let's start with the middle one, angle 5, angle 7, and angle 8. So if we kind of build the picture here, angle 7 is our exterior angle. Angle 5 and 8 are the remote interior angles. So angle 7 must be the greatest one. If we look at angle 1, 6, and 8, 1, 6, and 8, we would focus on this part of the diagram where angle 1 is the exterior angle. Angle 6 is a remote interior. Angle 8 itself is not a remote interior, but it's part of it, right? It's part of that second remote interior angle. So angle 1 must be greater than angle 6 and greater than that second remote interior angle, which angle 8 is part of. So it definitely must be less than that. And then again, if you looked at angle 3, 4, and 7, those would not work. It would not be possible. All right, our next theorem to apply is the base angle inequality theorem, which says that in any triangle, the side that is opposite from the larger angle is always the larger side, right? And then kind of going off of that, across from the medium angle would be the medium side, smallest angle would be the smallest side. So if we want to start with the large side, we're going to find the largest angle, which is 121, and that is opposite from RT. So segment RT must be the longest side, or the largest side. Then if we find the medium angle, which is angle T, the 30-degree angle, that is opposite from side RS, so that would be our medium side. And then lastly, the smallest side would be ST. We can use the theorem, we can also use the converse, right? Which is just the opposite order. So in any triangle, the angle that is opposite the larger side is always the larger angle. So we're just going to work backwards. Let's find the largest side, which was RS, right? That is opposite from angle T. So that must be the largest angle. Medium side was ST, the 9, so that's across from angle R. So that would be our medium angle. And then the 6 side is the smallest, and that's opposite from angle S. So let's look at a couple examples of how we could use this. So for this question, they want us to determine the largest or longest segment. So if we look at the first triangle, I know we have a 61-degree angle, a 59-degree angle, and just back to triangle sum theorem, we know that this must be 60 degrees. And then following the same idea, this one must be 61 degrees. So if we focus on just this left triangle first, right? Let's use the base angle inequality theorem. We're going to look at the angle measures to determine the inequality for the sides. So if we focus just on this triangle, right? I know that just based on the angles, side A would be the shortest, side B would be the medium side, and side E would be the longest. And then we're going to keep going because E shows up in this triangle. But in this one, it's across from the smallest angle. So we can keep our inequality going, right? I know E is going to be the smallest because it's across from the 59 degrees. Angle D must be larger than it because it's across from a 60-degree angle. And then lastly, angle C, right, is across from the biggest 61-degree angle. So if we set up our inequality that way, we should be able to see that side length C would be the longest segment in that diagram. All right, let's go with the converse of the theorem and find a way to complete each of these inequalities. So we're going to compare angle A and angle AJK, which is up here. Right? So if we focus just on this triangle, triangle AKJ, angle A is across from the side length that is 8, and angle AJK is across from the side length that is 11. So if it helps you write those numbers, write those lengths right near the angles, right? That should help you see that angle A is less than angle AJK. Let's try it again with two different angles. So angle Y and angle YJS. So here's angle Y and here's angle YJS in this triangle. The middle one. All right, angle Y is across from a side length that is 11, and angle YJS is across from a side length that is 10. So angle Y would be greater than YJS. All right, and we'll try one more set here, angle MSJ and angle SJY. So we're going to find each of those. Here's angle MSJ, and here's angle SJY. Something to notice, though, each of those are across from a side length that is a 10, right? You can't just automatically go and say that those angles must be equal because they're not from the same triangle, right? Even though they're across from side lengths that are the same, they're each 10, it doesn't mean that those angles are equal unless it was in the same triangle. Since these are different, we want to think back to something else from earlier in the video that we could use, right? And that's going to be the exterior angle inequality theorem, right? Angle MSJ, right, is an exterior angle, which means it must be greater than the two remote interior angles, than its two remote interior, which would be angle Y and angle SJY, right? So since angle MSJ is the exterior angle and SJY is one of the remote interior, that first theorem from the video tells us that this must be a greater than sign, right? And if you want to make a little note to yourself, the reason for this is the exterior angle inequality theorem. All right, the last theorem that we're going to learn about here is the triangle inequality theorem. And really, all that you need to know about this is that when you're given three lengths, they don't always form a triangle, right? If you think about three pieces of string, right? And you want it to connect them to form a triangle. They need to have certain lengths in order to be able to connect and to still have some area inside of them. So the way that we're going to use this theorem is to look for the sum of the length of any two sides to be greater than the length of the third side, right? If those conditions are met, a triangle could be formed. Again, it's the sum of any two side lengths. But personally, if I see a problem where I'm given three lengths and I want to determine if it can form a triangle, I'm going to take the two smaller sides, if possible, add those up and make sure that their sum is greater than the larger side. So for this one, I'm going to check. Does 3 plus 4 make something greater than 5? Well, 3 plus 4 is 7. 7 is greater than 5. So this one does work, right? It will make a triangle. And just to wrap in a little review here, the side lengths are all different, so it would make a scalene triangle. If we look at the next one, 3, 5, and 9, let's check. 3 plus 5, is that greater than 9? Well, 3 plus 5 is 8. 8 is not greater than 9, so this would not form a triangle. What about 7, 7, 7? Well, pick any two of them. 7 plus 7 must be greater than the last 7. 14 is greater than 7. It works. And we know that this must be equilateral, right? Where all three side lengths are the same. And then the final one here, 4, 4, and 8. If we do 4 plus 4 and check if it's greater than 8, 8 is greater than 8. Right? Remember the significance of your inequality symbol. This is not true, right? 8 is not greater than 8. So this actually does not work. not a triangle, because it's not greater than or equal to. It has to be greater than the third side. If you think about this, the two smaller segments, the 4s, they could connect to make the 8, but they wouldn't be able to stretch out and make area inside the triangle. So this would really just make a straight line. So that one's not going to form a triangle. The other way that we could use this theorem is to determine the range of lengths for a triangle. So like if we tell you that a triangle has a side length of 3 and 12, what are all the possibilities for the third side, right? You're not going to get one answer here. You're going to get a range. Typically, we would represent that with a variable. We'll use x for this, right? So it's going to be between two bounds, right? An upper and a lower bound. Right? And the way that we're going to do that is just to take the two lengths that they give us. We're going to take their difference, so 12 minus 3, which gives us 9. And then we're also going to take their sum, 12 plus 3, which is 15. Right? So I know if my third side is between, not including 9 and 15, if it's between 9 and 15, a triangle would be formed, right? And you would be able to check it like the 4 problems we did above. Let's try one more, 14 and 20. Right? I know my third side will be in a certain range. I'm going to take the difference, 20 minus 14. I know my lower bound would be a 6, and then take the sum. 20 plus 14 would tell me the upper bound is 34. So any length between those two numbers would satisfy it. Let's show an example with a little bit of algebra here. So let's say that they give us 3 angle measures, A, B, and C. They're shown with expressions, and we want to list the side lengths in order from largest to smallest, right? First thing we need to do is figure out, well, which angles are the largest, medium, and smallest, because then we can apply the theorem from the first page, right, in order to decide which side length would be the same. We'll be able to apply the base angle inequality theorem. So let's start with what we know. Well, angle A is 3x. Angle B is 2x plus 18, and angle C is 62 degrees. And we have to find a way to relate those, right? We can go back to chapter 4 and say, well, I know that the 3 interior angles in any triangle will add up to 180 degrees. So let's set up that equation. 3x plus 2x plus 18 plus 62 equals 180. Again, addition is commutative. You can add them in whatever order you would like. If we simplify this, 5x plus 80 equals 180. So 5x equals 100. So x must equal 20. Right? We want to make sure to use that answer, right? X is 20. I know angle C is 62 degrees. Angle A, 3x, is 3 times 20, or 60 degrees. And then angle B, 2 times 20 plus 18, this would be 58 degrees. Double check, make sure you didn't make a mistake. 62 plus 60 plus 58, make 180. So you didn't make a miscalculation. Now you just need to use the base angle inequality theorem, right? I know my largest angle was angle C, the 62 degrees. That was across from AB. So AB would be our longest side. CB, which is across from the medium angle, would be the medium side. And then lastly, AC would be the smallest side. So again, kind of a nice summary of some things that we've done, but you may see a problem like this with a little bit of algebra involved. Okay, the last type that we're going to do is a question like this, where we determine the range of possibilities for a side, this time using a little bit of algebra. So let's say that they give us this triangle. 2 sides are given as expressions, right? AB, the one side, is given as a number, right? We know that that's a 10. So we're going to do a couple different things here to determine the range, right? But again, the idea is, and I'm going to put my final answer when we're ready up here in blue. The answer should be a range, right? Like we've been practicing. But it's going to be a little bit more involved as far as how we get that. So we want to first account for the 3 possibilities, the 3 cases, right, that we learned in the triangle inequality theorem. So I know that the sum of any 2 sides must be greater than the third side. So I want to basically try all the possibilities. So I know if I add up x plus 4 and 3x plus 6, well, that must be bigger than 10. So that's going to be my one possibility. X plus 4 plus 3x plus 6 is greater than 10. And I'll solve that in a second. Then I want to do my next one. Well, x plus 4 and 10 must be greater than 3x plus 6. And then I'm going to do the last possibility, right? 10 and 3x plus 6 must be greater than x plus 4. Right? Again, we know how to solve an inequality. Let's combine some like terms for the first one. So 4x plus 10 is greater than 10. 4x is greater than 0. Right? That is okay. You can still solve that one. That's going to be x is greater than 0. So this is going to be one kind of part that helps us get our answer. So we're going to save that one. The second inequality, if we simplify it a little bit, x plus 14 must be greater than 3x plus 6. Let's get variable terms to one side, constants to the other. If we simplify this one, depending on how you do it, when I simplified it, I got negative 2x is greater than negative 8, right? I know my next step is to divide by negative 2. But again, remember, anytime you are working with an inequality and you multiply or divide both sides by a negative, right? We divided by negative 2. You have to reverse the inequality symbol. So maybe if you're, copying this down, maybe make a note to yourself. But this one would be x is less than 4. Right? You want to make sure to remember that step. And then again, if you solve the last one there, that would give us x is greater than negative 6. So we're going to come back to those. The last thing that we have to do before we think about our final answer is to make sure we account for the restrictions, right? There are two sides that are shown as expressions. AC is x plus 4, BC is 3x plus 6. Well, we know if it's a triangle, right, you can't have a length that is negative, right? You can't measure something negative. So we want to make sure that we state, well, x plus 4, right, that one can't be, or it must be greater than 0. So x plus 4 must be greater than 0, and 3x plus 6 must also be greater than 0, right? And then if we solve each of those, we have x is greater than negative 4, and then x is greater than negative 2 would be the last one there. So once we do all of this work, this problem, we ended up with 5 inequalities, right? Here, 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 and here. And the way that you determine your answer, right, is to think about this. I want to look at all my greater thans and pick the biggest one, the greatest of the greater thans, and also look at the least of the less thans. And that's going to help me write my answer inequality. So there's only one less than, right? X is less than 4, right? So that's going to be my upper bound. There's only one choice for that. But then between all the other ones, right, think about a number line. I want the greatest greater than, the one that's farthest to the right. Well, it's not going to be negative 6 because I have a negative 4. And it's not going to be negative 4 because I have a negative 2. And it's not going to be negative 2 because I have a 0. Right? So I know for this problem, my range of possibilities must be between 0 and 4, just based on the 3 cases and the 2 restrictions.